Yes, hey fam, welcome back. Let's solve 169 majority element. And again, the question is pretty straightforward. You will be given an array n or array of size n, and you have to return the majority element. And what a majority element is, yeah, that definition also they have given. It is an element that appears more than n by 2 times, where n is the length of the array. And yeah, again, what they have given is there will always exist a majority element. So there's no need for us to wonder what to do if there's a majority element. And yeah, there are two ways to do this, and let me go over both. Yeah, and let me tell you what we can do also. Yeah, the first thing which should come to your mind on seeing this question is again hash map or dictionary. You can easily count the number of yeah. One thing I'll tell to you guys. Whenever you have any counting thing to do, it generally involves using a hash map or a hash set or hash map or a dictionary, whatever you want to call it. And yeah, and that is one way to do it. And since they have given that the element appears only n by 2, there is only one element that appears more than n by 2 times. There is another algorithm called Moore's election algorithm, and we can use that also. So yeah, we'll go over both of them and talk about the drawbacks of each. So yes, first let's go over using a hash map. Yeah, and the hash map is pretty straightforward. Yeah, I am using a default dictionary because I don't want to take care of conditions. If the number is not present, then go through adding it and all. Yeah. So there is another thing which you can do, which is using a counter. That's also a valid approach, but yeah, counter, what you have to do is you have to go through every element in the array once. But when you're using dictionary, it is not necessary for you to go through every element if you get to know that the count of that specific element is already greater than n by 2. Because yeah, just think about it, there cannot be more than two elements having count more than n by 2. There will be one element with count n by 2. And if you have, yeah, just think about it, it's simple math. If you have three elements who appear more than n by 2 times, then what will happen when you add n by 2 and n by 2 and n by 2? You will get 3 n by 2, which is obviously greater than 1, and that will never happen. So yes, now for I nums, just increment the position, the count of the element by 1. And if, yeah, d at the position I, you get it. And if it becomes greater than or equal to length of nums divided by 2, divided, not dot dot, divided by 2, then you obviously have your answer. You can return I. Yeah, I think this should work. Yeah, it's that simple. Okay, what happened? Output 1. Yeah, it's not see the test case 2 2 1 1 1. Yeah, it is not greater than or equal to, it is just greater than. Yeah, it works. No, let's just submit it. Yeah, the obvious thing with this is the space complexity. It uses an extra way to measure the count also. So yeah, that is the space complexity is O of n, mainly because if the final element checked was like the last element, imagine only on adding the last two you got, yeah, this example itself is a perfect test case. You will get the majority element only after checking the last element. So you will have to store all the values of nums in your dictionary, and yeah, that will obviously lead to O of n. And now let's go over Moore selection algorithm. And the drawback of this is that, yeah, it becomes complex to implement, especially if you don't know what it is. And yeah, but the plus point is that it uses constant space, which is O of 1 space. So yeah, again, what you have to do is, yeah, just think about it. Again, based on the same definition, their number will never appear more than n by 2 times. Yeah, the number can appear more than n by 2 times, but there will be one element which will appear more than n by 2 times, and it will, and there is no condition that every element in the array will appear less than n by 2 times, and you have to leverage that fact. So what you can do is you can keep a counter, or yeah, count variable which will count the number. And yeah, if 3 exists, then what you can do is increment count by 1. Yeah, to consider this one, yeah, if and you check, you will have a count and a majority element variable. And yeah, if the majority element is the ith value, the index value which you are checking, then you can increment the count by 1, or else you can decrement the count by 1. And by, at any chance, if count becomes equal to 0, that means that the element which you are checking was actually not the majority element, and you have to update your majority element to the current element which you're checking. Yeah, talking like that seems like tennis, but after I write the code and you go through it like 1 or 2 times, you'll get to know. You keep a track of count and majority element, you both set it to 0 and go through each element in nums. Yeah, the thing with this is that even though if the majority element was present in the beginning of the array itself, you will not get to know until you traverse the entire array. That's the drawback. So in the best case, the time complexity of the previous approach should be O of n by 2. Yeah, which is O of n only, but yeah, you consider if you had, I don't know, 1 trillion elements and then you divide it by 2, then obviously the time will be like much higher, much lower. But the thing with this is that you have to go through every element in the array. So yeah, if I becomes equal to the majority element, then what you have to do? Just increment the count by 1. And if else, if it is not equal to the majority element, just check. If count is equal to 0, then what it means? It means that the current element which you are checking may not be the majority element. So set majority to I. Else, what you have to do? Just decrement the count by 1. And now you can actually return the majority element itself because it will actually hold your value. Yeah, it works, and let's submit it. And yeah, it obviously submits. Yeah, again I'll tell about the time and space of both the approaches. In the dictionary approach, the best time, yeah, now I know everyone talks about the worst case first, but hey, let's talk about best case. Just look at the good things in life, don't go to check the bad things. So yeah, best case is that if the majority element appears in the first n by 2 times itself. For example, yeah, just consider that your array was like this. Yeah, then obviously on checking this element itself, you will get to know that that is the majority element. So the best case time complexity of this is n by 2, and the worst case is obviously O of n. And the thing with Moore's algorithm is that Moore's selection algorithm is that the best and the worst and the average, every case is O of n. It will never be less than O of n because you have to check till the end of the array. And yeah, that's it. Just go through the code once again if you did not understand how it works. Yeah, thank you.